Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic two-dimensional random variables, we are going to see what is correlation and its applications in this video. So first let us see what is correlation. So here this correlation means measure the strength and direction of a linear relationship between two random variables. So this is what is discussed. This is strength of relationship between two variables are discussed in this correlation. Mostly this is used in or correlation is applied in random processes fields. So we are going to study what is zero correlation, negative correlation, positive correlation. So here is the design thinking cycle for understanding the correlation. So first is we need to identify the user. So identifying the challenges users faces are the empathy part. Next is an ideate. So the problems are brainstormed to find the solution. Next is a prototype. How to solve the problem is done there. Next is testing. The prototype developed is tested in the real life problem. Then we'll be refining the outcome of the test in the iterate part. So here is the empathy, in which the challenges, learners' empathy are discussed. Next is define part. So in define part we will study what is the pattern of the correlation. Next, relationship analysis. Next is prioritization. Next is targeted solution and guiding subsequent stages. So in pattern identification, first we'll recognize the trend and connection in data, that is the relationship between x y are identified. Next, relationship analysis. So understanding how different factors interact, what are all the factors affecting, are all discussed in the relationship analysis. Next is prioritization. So focusing on the most impactful issues. Next is target solution. So developing the solution in such a way that the problems are sorted out, the problems are given solution is discussed. Next is guiding subsequent stages. So ensuring the clear directions for the design process. Next is the power of correlation. So where and we in what are all we can apply this correlation. So in economics, this correlation is applied to analyze market trends and investment strategies. Next, in finance, assessing the risk and return in financial markets. So since it is the study of relationship between two variables, so if x, how well this x and y are connected is identified, then we can use this for risk analysis. Next is healthcare. So identifying factors affecting patient's outcome. For example, if we are using medicine for a patient, if the medicine suits very well for that patient, then we will continue to give that medicine. If it's having a consequence or some other consequences, like if the medicine is giving side effects, then we'll stop that medicine. So if both are connected very well, we'll proceed with that. So in social sciences, understanding societal patterns and behaviors, we can use this correlation. Next, informing strategic choices and policies in design decision making, also we can use this correlation. Next is the unveiling the multi-faced role of correlation in engineering, where all we can use this correlation in engineering fields. For example, in signal processing, we can use this to find the autocorrelation, cross correlation and all. Next, in structural engineering, in environmental engineering and in control systems also, we can use this correlation for studying the strength of the relationship between any two variables. Next is the mind map of what we have seen in this video. First, we have discussed about the types of correlation, that is a positive correlation, negative correlation, autocorrelation, cross correlation. Next, design thinking cycle we have discussed. Next, problem definition enhancement. Next, we have seen where all we can apply this design thinking, like in the fields of economics, finance, healthcare, social sciences, and design decision making. We can use this, and also in engineering applications, for example, in um, random processes, control systems, and all, we can use this correlation. So here is the small assessment. So here, if the correlation coefficient between two variables is +1, it indicates a positive correlation. If the correlation coefficient is -0.8, then it is a negative correlation. Next, if all observations lie exactly on a straight line with negative slope, then the correlation will be -1. Since it is a negative slope, it will be -1. So here are the references for this, and thank you.